This is a great morning. I am Mr. H. Thank you for joining me. I hope you all are having great mornings. We're looking here at coordinate geometry involving circles. Fair game for any type of test. Two questions. Our first question, and everything here is related to circles, but on a coordinate x and y axis plane. A circle has a center 2, 2. The radius is 3. Find x-intercepts, if any. The only reason why I'm putting if any, because you could technically have a circle supposedly right here, and the radius may be so small that the curve will never touch the x-axis and you'll have no x-intercepts. You could have a situation such as a circle like this, and then you know you're having two x-intercepts over here. We have to determine if this specific circle here mentioned in the question has any x-intercepts, and we have to calculate those. So the first thing you have to do is develop your equation for a circle, and you know you have center, you have h, and you have a k, the center, and you're looking at equation of this form: x minus h whole square plus y minus k whole square is equal to r squared, the radius. That's exactly how you put everything over here. You'll have a x minus 2 whole square plus y minus 2 whole square is equal to r square, which will be 9. 3 squares are 9. If you were to graph it out, you know you have something 1 and 2 right here. Here's your circle. I'm doing a very rough graph. It doesn't look like it's a very good image here of a circle, but we don't know if the x-intercepts are truly involved or not. We're imagining and assuming they would be. I have a feeling they would be, but we have to calculate these x-intercepts. So we have developed our equation form over here, and we have to determine the x-intercept over here. So be aware of what you're doing. When you're doing an x-intercept, you have some value plus and minus x, assuming this will be the case, and the y value will be 0. Remember, at an x-intercept the y value is 0, but at a y-intercept the x-axis values are 0. So keep that in mind. That distinction should be kept in mind. In this specific instance, your y value will be 0. You'll 0 out the y and you'll solve for x. You'll have x minus 2 whole square plus 0 minus 2 whole square is equal to 9. You see, I zeroed it out. You'll have x minus 2 whole square is equal to, you'll have a 4 here, you'll take 4 on the other side, you'll have a 5. We're solving for x. X minus 2 is equal to root of 5, but you can do positive and minus roots of 5. And then x is equal to plus and minus root 5 plus 2. We can write this in coordinate forms if you want. You'll have a minus root 5 plus 2 comma 0. That's my x and my y value, and your other one will be positive root 5 plus 2 comma 0. X and a y value here have been developed for you, and you can get a good indication of what these really are. You can do root 5 and you can do minus plus 2. I'm getting a minus 0.236 here, and then you can do a root 5 plus 2, you're getting a 4.236. Minus 0.236 and a 4.236 somewhere here, and our center is over here, so you have a circle which will develop here, and these are my two x-intercepts. So that's what the question was asking. In all instances, anywhere from this point to any of these, from the center to any of these points, will always be a radius here of 3, and that's exactly what you have. This question has been done. These are your x-intercepts, and they're good. So this circle did have x-intercepts. Our second and last question is this: we have to find the equation of a circle which has a point minus 2 comma 1, meaning the curve of the circle falls on this point. It has a center 0 comma 4. If you were to graph it, you don't have to, but if you were to graph it, you'll get an idea of what you're looking at. Minus 2 comma 1, 1, 2, and right here. That's exactly what you have. Here's your center, here's your point, and the curve is like this. I'm being cut over here, but you can see the center and this specific point P falls on the curve. How can we go about determining the equation? Well, the equation is right here. You fill in the items: x minus h whole square plus y minus k whole square is equal to r square. We have the center here, and this is 0 comma 4. We know h comma k represents our center values. Well, h over here is a 0, k is a 4. You plug them in, you have a x minus 0, which is meaningless. You just write x square plus y minus 4 whole square is equal to r square. We still have to determine the r, but we do have x and y values. The x and y values are right over here of our point. Plug them in. You have a x value and a y value: minus 2 whole square plus 1 minus 4 whole square, which is my y value, is equal to r square. I have a 4 plus, I have a minus 3 square is a 9 is equal to r square, and you know r here is equal to root of 13. When you have all of these items, you have this right here, you can develop your equation, and I'm going to put the equation right over here for you in a good clean manner right over here. I have a x minus 0 whole square. You can write it as that if you want. I have a y minus 4 whole square is equal to root 13 square, because it's r square, which will be just 13. This here is your equation. If you want to just write x squared over here, you can. You can do x minus 0 whole square. It's all good. But this here is your completed equation, and it's done. And that's about all we have to present for you in this specific video. Have a great rest of the day. Bye.